okay? And so that leads nicely into this discussion of fuel values and food values. I'm only going to talk about this very, very briefly, okay? So fuel value is, I kind of mentioned this earlier with the bomb calorimeter, okay? So fuel values and heat of combustion values are very similar. And so we'll say this delta H of combustion is the same thing as delta H of reaction, specifically for a combustion reaction, right? So we talked about how that delta H of reaction can be generic, right? We can use it for any type of reaction. So when we say specifically delta H of delta H combustion, it's the same as delta H of reaction, okay? So we just calculated that for octane, right? But now we note here that there are several other hydrocarbons that we have. Methane, so that's what you have in your stove, okay? And so let's see, oops, and kilojoules per gram, I just noticed that. Typo, kilojoules per gram. And so that's the kilojoules per gram of heat released, okay? So this is very straightforward to interconvert these two things. So for example, with methane, this negative 802.3 kilojoule per mole, okay, I can easily convert that into its fuel value by the following. So I just recognize that 1 mole of methane is, what is it? It's roughly 16.04. I've got that memorized. 16.04 grams of methane, okay? And so when and also for fuel value, you notice that it's all positive signs because in fuel value, we just report the positive value because we recognize that all combustion reactions are going to be exothermic, okay? So now if I just divide that by its molar mass, okay, yep, then I get 50.01. You can see that matches that nicely, kilojoules per gram. So these fuel values are much more useful because, again, we don't have a mole meter in lab. We have a mass balance, right? So you could weigh out how much gas that you're using in a reaction and very quickly get the total amount of kilojoules. So for example, suppose I burn 1 gram of methane. Well, if I burn 1 gram of methane, then I'm going to get 50.01 kilojoules of energy. Okay, so that's why the fuel value can be more useful for engineers, for example. And the very last thing I want to talk about, just very, very briefly, food values. Okay, so some of you already knew this, but in case you didn't, this is pretty interesting. So look at this on this can of soda, 140 calories per can. Well, check it out. A calorie is actually a unit of energy. And we have to keep track of this. So cal with a lowercase c is exactly 4.184 joules. And then I said, does this number look familiar here? Hopefully it does. So the heat capacity, the specific heat capacity of liquid water is 4.184 joule per gram per degree C, which is the basis of the unit calorie. And why is that? Well, because your body is mostly, oops, I wrote that backwards on this thing. Your body is mostly made up of water. So when you think about when you're consuming food for energy, where does all that energy go? An enormous chunk of it goes into just maintaining your body temperature, right? We did this calculation. Heat equals mass times CS times delta T. This is what your body is doing. It's maintaining some type of temperature, right? It's keeping your body warm. It's keeping your body much warmer than the surroundings, right? If you think about this system versus surroundings, if you're the system, you're about 39.5 or so degrees Celsius, I think 37.5 degrees Celsius, but the surroundings are like 25 degrees Celsius. So that's a huge temperature difference that your body has to maintain, which is why traditionally we give the unit of calories as the specific heat capacity of water, because your body is mostly water. Now, that being said, the calories that's reported on this can of Coke is actually a kilocalorie. So this is what I'll call a science calorie. So just 4.184 joules. A dietary calorie is actually a kilocalorie. Okay? I can't spell and talk at the same time. Yes, so that means one dietary calorie is actually equal to 1 kcal, which is 4,184 joules, or 4.184 kilojoules. Okay, so on this can of Coke where it says 140 calories, so that's 140 dietary calories, which is really going to be 140,000 regular calories. Okay, that's all that I'm going to say about the calorie and as a food value. Okay, so I think that puts a wrap on it, folks, for thermodynamics. So I know this is a lot, asking you to get through all of these videos this week. So thanks for doing that and getting caught up. I will see you during our live meetings this week.